Good afternoon, good evening, good morning, ladies and gentlemen. Welcome to Tutorials with Aubrey, where you get exclusive mathematics tutorial videos. Now, you can subscribe to our YouTube channel, hit the notification bell, and give us a like. Now, in today's video, we look at some interesting concepts in probability. And to be specific, we are going to deal with strategies that we can use whenever we are solving probability. Right, so that is strategies we are going to be using to solve probability questions. Now, the first thing that you should note is that whenever you're solving a probability question, it will fall into these categories. It's either the question you're solving falls in the category of independent events, okay, independent events. All right, when we say an event is independent, we are saying when that event happens, it will not affect the happening of other events. An example that I can give here would be maybe a school, for instance, is looking for 2 mathematics teachers to employ. Okay, and it so happens that only 2 teachers show up for the interview. Now, if one teacher has been employed, it will not affect the employment of the other teacher because there are 2 job openings. Now, a fact you should also know about independent event is that the probability of those events happening together is equal to the probability of event A times the probability of event B. This is a fact you should note whenever you're dealing with independent events. And as independent events is the opposite, which is when you're dealing with dependent. All right, dependent events. Okay, dependent events is when one event happens in one way or another, it will affect the happening of another event. In one way or another, it will affect the happening of the other event. Okay, for instance, in the same case where one teacher is only needed at that school, okay, and 2 teachers show up, then let's say one teacher gets employed, then the other teacher will most definitely not have the job. But in a case where they say, okay, we can give you another job opening, there's another job opening for this, okay. So we are saying these events are dependent because it affected the outcome in one way or another. Another concept linked to dependent events that should not be confused with dependent events, however, is mutually exclusive events. Okay, mutually exclusive events is where when one event happens, it completely affects the happening of another event, completely happening of the other event. Right? Independent event, it will some way affect the happening of another event, but in mutually exclusive events, when one event happens, the other one cannot completely happen. And for mutually exclusive events, the probability of 2 events happening is equal to 0. So majorly, we are going to be looking at whenever we are solving probability questions, we should ask ourselves, what type of events do we have? Do we have independent events, right? Then if the events are independent, then this formula should be satisfied. In some cases, you'll be asked to show that events are independent. And if they are independent, this formula should be satisfied. And this is the formula we'll be using for independent events. Yeah. Then on mutually exclusive events, two events happening is zero, right? So this is the formula we are going to be using for mutually exclusive event. Now, it's very important that whenever you're solving a probability question, you need to identify your sample space. Now, your sample space tells you exactly where you're picking from. So if you identify your sample space and denote the type of event that you have, then the problem is solved. Yeah, I would say it is half solved. And the other thing is we need to know basic axioms of probability, right? Axioms are, okay, just say axioms. These are facts, axioms. Axioms are facts, okay? When you have two events A and B, the probability of those events happening, all of the events happening together is equal to the probability of event A happening plus probability of event B happening minus probability A and B. All right. So this is the first axiom, and we see that this part of the axiom, okay, will be affected depending on the type of event that is happening. So if the event is mutually exclusive, this part will be zero because we said mutually exclusive events, they cannot, so A intersection B is zero. If they are independent, we're going to have probability of A times probability of B right here. So that is the first axiom that we should look out for. That's right. The second axiom, probability of any event complement is equal to 1 minus probability of that event. Okay. Sometimes you see probability of A intersection B or A union B complement. This is equal to probability, sorry, this is 1 probability of the event inside the complement, which is a intersection. So that is the complement case. We also have probability of an empty set. Probability of an empty set. Probability of an empty set is equals to 0. Of set is equal to 0, right? This factor. Probability of the sample space. Probability of sample space. Say the sample space is equals to 1. Okay. What is the probability of everything in the sample space happening? It is 1. Okay. Let's say you toss a coin. What is the probability that you get heads or tails? Heads or tails are in the sample space, so the probability will be 1. The other one that you should note is a probability of A. Let's say you have A on the complement part, A intersection B complement. Okay. If the complements are on both letters, when you can factor out the complement, so this is probability of A intersection B. Okay, then I mean it is union now, so this will change to A union B. So the sign changes. A union complement. Okay, so this sign changes if it was intersection, it becomes union. there was union, it becomes a section. So this is what you need to look out for. Okay, this intersection becomes union section. So the complement can be factored out, right? Then also what you should also consider, when you have probability of say A complement intersection B, right? So this is the probability of the element that has no complement, probability of element that has no complement, which is B minus probability of this operation that is A intersection section B. Okay, and you can manipulate the complement, so on and so forth. So now these are the strategies that you should know, and let's look at some problems that we are going to use to solve strategies that we've learned here.